Science. Topic: Electricity. Electrons were discovered in 1897 and was assigned a negative charge. Electrons are free to move in a conductor like copper wire. This flow of electrons through a conductor is called electric current. The figure shows a light bulb, switch, and battery connected by copper wire. This conducting path through the switch, bulbs, copper wire and battery is called a circuit. When the switch is on, it closes the circuit, makes a complete path. Because of this complete path, electrons can flow from the negative terminal of the battery, through the wire, through the bulb, and back to the positive terminal of the battery. So current flows because of the potential difference between terminals of the battery or cells. By definition, electric current is the rate of flow of charge. O current equals charge by time, or I equals Q by T. The unit of current is ampere. Time is in seconds and charge is in coulomb. Let's do a problem. The current given is 40 ampere and time 2000 seconds. We are asked to find the total charge which flows from the battery. Using the formula we get Q equals I into T equals 40 into 2000 equals 8000 coulombs.
A battery gives potential energy to the electrons it pushes out, so when battery is connected to a circuit, having a bulb connected, the energy is converted to light and heat by the bulb. The potential difference, often called voltage, is the measure of the difference in electric potential energy per unit charge between its two terminals of the circuit, the positive and negative ends.
The potential difference across the battery can be measured using a voltmeter. Another definition of potential difference or voltage across the terminals of the battery is a measure of the difference in potential energy per unit charge between 2 points in the circuit. Potential energy is measured in joules. Here in the diagram, the potential difference across the battery is 4 volts. That means 4 joules per coulomb are gained across the battery terminal as per definition of potential difference. So the battery gives 4 joules of potential energy to each coulomb of charge. The energy is converted to light and heat by the bulb. Here in the example, the potential difference across bulb 1 is 1 volt. The potential difference across bulb 2 is 3 volts. Ohm's law and resistance. Resistance is how much a material resists the flow of electricity. Resistors are devices specially made to provide resistance. When a resistance is placed in a circuit, they reduce the current flow. Ohm's law says, voltage equals current times resistance. Or simply, V equals I times R. Resistance is measured by taking the voltmeter reading for voltage and then ammeter reading for current and then use the formula to calculate resistance. We know that resistance is how much a material opposes the flow of electric current. The formula is R equals ρ into L by A, where ρ equals resistivity of the material, L equals length of the wire, A equals thickness or cross-sectional area of the wire. So longer wire means more resistance, thicker wire means less resistance. Different materials have different resistances. Resistance usually increases when temperature increases. In a series connection, resistors are joined end to end, forming a single path for the electric current to flow. The same current flows through all of them, but the total resistance adds up. So the combined resistance of resistors in series in the example is R equals R1 plus R2 plus R3. When resistors are joined in parallel, they give multiple paths for current to flow. The same voltage is across all resistors, but the current is divided. The combined resistance of resistors in parallel is 1 by R equals 1 by R1 plus 1 by R2 plus 1 by R3 in this example. Let's do a problem with 3 resistors in series with a 20-volt battery. Total resistance is 10 ohm. Current is same across all points in the circuit. So current is V by R, which is calculated to 2 ampere. Voltages across resistances change, so V1 is 4 volt, V2 is 6 volt, and V3 is 10 volt. Daily life applications of series connection. In decorative lights, the bulbs are connected one after another. If one bulb stops working, all the bulbs go off. Old Christmas lights also work in the same way. Daily life applications of parallel connection. In home wiring, all appliances get the same voltage and can work separately. In cars, even if one headlight fails, the other continues to work because they are connected in parallel. Electric power. Electric power, P, is the rate at which electrical energy is consumed or dissipated in an electric circuit. The SI unit of power is the watt, which is equal to 1 joule per second. Power, voltage, current and resistance are interrelated. Formulas are derived from Ohm's law and the definition of power. Power is voltage by current. Also power is V² by R, where V is voltage and R is resistance. An example problem is given to find current and resistance. Power is given as 60 watt and voltage is 120. We use the equation for power to find current. Answer is 0.5 ampere. Heating effect of electric current. If current I ampere flows for time t seconds through a resistor R ohms across which a potential difference, V, volts is maintained, the amount of heat energy, H, in joules is given by the formula. H equals I²Rt. An example problem to find heat energy is given. From the values given and using the formula, the heat energy is calculated to 200 joules. Daily life applications of heat energy from electricity. The heating effect is intentionally utilized in appliances that require heat, which are often made using high-resistance materials like nichrome. The heat energy is used for heating electric heater. The heat energy is used to light a bulb. The heating effect is utilized in electric fuse for safety purposes.
Video by Anand Mohandas.